What takes us to the top 300? It's not just about us, it's about the problem that we are obsessed about solving. At Vibecon, we are going to build a distributed compute environment. So the idea is to solve the problem of accessibility of high-end compute power. Basically, if you see, there are many people who can't afford GPUs or any hardware items which are costlier, especially in countries like India. And our platform is going to be a one-stop solution for them. So people can come to a platform, run their task. For example, think of a computer science student coming up with a AI model fine-tuning. Let us dive into the understanding of the system that we're going to build. So basically, you can see there are three entities. First one is the client over here. Second is the host, you can see here. And the third is the coordinate layer and the orchestration layer. So the clients are those who wants to execute their job, and the host nodes are those who have shared their compute power. So client one can be anyone, anywhere in the world who wants to do a task, a compute task, and host similarly can be anyone who is sharing his compute power or his machine's compute power. Now, let's say client one, assume an example or a scenario, client one wants to execute a job, for example, an AI model fine tuning, but client one doesn't have that much of capability in its server or in its machine or laptop to run this job. So what client one does, client one comes to a platform, says, hey, please execute this job for me. So our platform takes this job, assigns a compatible host to it. It can be host, it can be multiple host, and it assigns this job. Let this node, for example, node 2 and node 3, execute this job parallelly. For example, this job can be split into two parts, and let's say split 1 is being executed by node 2, split 2 is being executed by node 3. Split 2 and split 1. And both of this execution is again sent back to my orchestration layer, and my orchestration layer accumulates this both execution part or this output and sends back to my client, or sends back the response to my client or the final outcome of the execution. Now let us dive into a demo where we are simulating this whole process. This is my client machine. This is our platform's backend server, for example, and these are two hosts. Those are sharing their compute. Now let's just dive into the client side. For the demo purpose, we have set a compute dashboard in which we have a code section and an input section, and there is a pre-written code to reverse a string. An input, let's just write emergent. We have typed emergent, and as we click on run code, we'll come to see the output, which will be the reverse string of emergent. We can see that the reverse string of emergent came, but the catch is over here. In our server, backend server, it's just taking the job from the client. So the job has been received from the client, so that the client requested, and this job was transferred to one of our hosts. So this host received the job, and it executed in this host machine, and it was sent back to the client as an output, which is the reverse string of emergent. If money wasn't a constraint, I would evolve this into a fully autonomous compute fabric where compute is globally available, an AI-driven system that intelligently routes workloads and runs them in secure sandboxes and delivers real-time compute across a global edge network.